I'll write that stuff on the board later and we'll go over it later. So. Okay. And does anybody have any questions now at all? Anybody at all?
You can sit in my spot, it's fine.
About our basic rules, anybody at all with pure competition?
I think so.
With PC, right, you're always gonna, what we should do is we should do this. What do I do with that red? That's right here. Should do this. All right. Profit maximization, what rules? What do you have? Any firm, don't care if it's PC, MC, O, what do we have? Profit maximization, what do we do?
MR equals MC.
Okay. Or? Okay, very good. All right, when marginal revenue is greater than the marginal cost, what should you do? Produce more or less? And when marginal cost is greater than marginal revenue, what should we do? Less. So the basic rules here, okay? Is there anybody in here that doesn't understand the basic principles then of cost functions? Marginal cost function has to intercept the bottom. You understand everything now about how to identify then if profits are being shown or losses. Is everybody good on this? You'd be able to calculate that area so you don't get any of the easy items wrong. Okay? Does everybody understand in the short run, all right, what happens? This is going to be a little bit more difficult here, but does anybody have any questions? Why prices might rise in the short run above average total cost? Remember, this is what's going to be really important about PC. All right, bad marker. Let's try a different one here. You know what, this orange one has been working pretty well. With PC, we'll drop one more time here. In the long run, we all know all the products are the same. So this is the marginal revenue function. This is the demand function. It's price, it's average revenue. This has to be the long run, all right, situation or equilibrium. Okay. That's an M. This is long run. We're going to put some rules up here. Price is going to be equal to the marginal cost of producing the item. The price is also equal to the, and this is the important thing, we call it efficient minimum scale. If you see that word again, that's at the very bottom of your average total cost function. That would be really, really efficient, wouldn't it? So we're going to put minimum, all right, A, T, C. Those rules have to apply, all right, for pure competition. So I can't remember where we left off. Did I go through all of this information then with you in terms of pure competition? We showed you a little bit, marginal revenue, marginal cost. We noticed that this is also not just profit maximization, but what else is it? It's loss minimization. Right, it's both these rules right here, okay? I think we got through all of that. Did I talk at all about then the shutdown rule?
Yes.
Okay, you know what that is then? We can put that up here. We can put the shutdown rule up here. No, shutdown is not exit. Don't confuse yourselves, right? Shutdown means that you're just gonna shut down for the short time. I think a golf course is a really good example. So what is the shutdown rule? What is that?
Where if you can't cover your variable.
So whenever then, okay, because sometimes, you know, they're gonna list it as such, when P is less than what? The average variable cost of producing the item. You need to shut down in the short run. This is a short run. Now, if the price is below your costs of paying your laborers, they're your variable costs, if that happens in the long run, should you maybe exit the industry? Okay? We'll show you here again with a little example. Remember, you're getting a crash course here. I think it's also very, very important. I've seen questions like this. Remember, what is the distance between ABC and ATC? What is that again? I'm a patient here, me.
Fixed cost, yeah.
Very good. Isn't this our average fixed cost function? As we make more and more, it's gonna get closer to the margin, or excuse me, to the x-axis. So we take AFC plus ABC to get ATC. Did you notice that these get closer together as you produce more output? That's because your average fixed cost function is getting closer and closer to your x-axis, isn't it? Okay, so when you look at that graph, what that is showing you is that you're covering, all right, this is what? The loss minimization rule. This is where you're gonna minimize your losses. You're gonna produce 6 items because MR, all right, is equal to MC. MR is equal to MC. So you can calculate your losses, okay? All we're gonna do here is we're gonna look at, all right, what is the average total cost of producing the item 9167, all right, which price you're getting is $81. You got a problem. Your average total cost of producing the item is 9167, but you're only getting 81. So are you operating at a loss? Yeah. But are you covering your variable costs? Are you able to then pay your laborers? What you're really doing right here is that what you're saying is, stock, well, I can cover some of my fixed costs. That's this gap between the two. All right, not all of them, but I can cover some of them, and I can cover then my laborers. When that price falls below average variable cost, now you can't even cover your what?
Workers.
Can't cover your workers and perhaps some of your fixed costs. But do you still stay in business until things improve? Yeah, absolutely. And you're saying, well, why am I shutting down? Well, you'd be better off to shut down. You're producing 6 items and you can't cover your fixed costs. If you just shut down, all right, you're only out what? Your fixed costs. So that's why you're gonna shut down right there. But you're not gonna exit. So that, I promise you, will be on. That will be on the exam. Absolutely. They're not gonna let you escape not knowing the shutdown rule. And maybe sometimes it's where to identify it on a graph. Sometimes it's where do you identify it in a tabular form. You know, maybe I have that here as well. Okay, should you exit the golf business and enter the next best alternative? No, you just shut down for the winter months. Because what's gonna happen in the spring months? Will demand pick up? I could draw, all right, an industry graph over here. Remember, the industry's setting the price. You have no control over price. So notice now where I drew that, if the demand, all right, were to rise, and let's put our other demand function on here. Maybe we could go like this. Oop, that's supply function. Oops, you fat head. Let's do this. Okay, let's do this. All right, let's put a different demand function on here, D1, D2, okay? If the prices had fallen, all right, in the fall season, will they pick back up in the spring? Then the industry establishes the price, and now we have a new what? We have a new price established. Okay, make sense? And now, MR equals MC, we're gonna produce right here, that may be the 8th item, and now are we showing a profit?
That was showing a profit. Now, getting into the golf course industry is not pure competition, is it? I just use that as an example. All right? If it were in pure competition and that was occurring, what would happen? Profits are being shown. It's really easy to do. Anybody could do it. There's no entry barriers. What would happen? Increase in supply. And then that would bring us right back down to what? Right here at minimum. I drew it too far, but right at minimum ATC. And I'll show you an example of that here when we look at our next item. So let's do this. Nope, I gotta walk over here. Okay. All right. So this is our last slide here. The break-even point then, or where you're earning a normal profit, okay, is right here. Okay. You're covering what? What is your average total cost function? What did we say that we're also going to include with it? Your implicit costs. So it's not just your costs of making the widgets, it's also what else I could be doing. So when the price is equal, all right, to the average total cost of producing an item, and it doesn't have to be minimum, okay? When the price is equal to ATC, you're covering all of your costs of production plus what else you could be doing. So you're earning what? Zero economic profit. Zero economic profit, all right, is a normal profit, or there's no incentive to go do something else. That is your long run equilibrium. Does everybody see that again? Because I drew it up here on the board. In the long run, this is what your equilibrium is going to be in pure competition. Long run equilibrium. Long run equilibrium. Okay? Does that make sense? See how they're showing your shutdown rule here? If price is to fall below your average variable cost, you need to shut down. In the long run, you might want to exit, but in the short run, okay, not so much. Remember what I said, this could be on the test, this is really important. The, all right, supply function for a pretty competitive market is that MC function above ABC, because you wouldn't be in business below that. So that's going to be your supply function. And there it is. Okay, so let me show you a few examples here. Let's go back. Let's open up long run competition notes. All right. They don't do a lot of questions with decreasing, increasing costs. Industries, it's usually constant cost industry, which you guys should probably see. All right. Just so I show it to you here quickly. So once again, you're a price taker in pure competition. Price taker. The market establishes the price. Right? You see how these two are correlated, and I think I showed that to you before. Right? So let's look at a couple scenarios here. This firm is in long run equilibrium, isn't it? The price that they get for the product, if we put $3 over here, let's put $3, okay? Is that equal to the average total cost of producing the item? Yep. Is it equal to the marginal cost? Each time they produce another item, what's it going to cost them? $3. Do you see how we are in equilibrium here and we're super efficient? Okay, pretty simple. So let's do this. Okay. I'm not going to read through all of this. I've already explained it to you. Long run depends upon, all right, entry and exit of other firms in the industry. We've already talked about that, all right? Normally what you guys are going to see, especially on a Clep test, is just a constant cost. If you see that term, don't get alarmed. It's just going to say if constant costs exist in the industry. And I'll show you what that means, okay? I'm going to show you that here in a second. Okay, P is equal to ATC, and it should be minimum, and P is equal to MC, zero economic profits. We all know this, okay? So let's do this. I want to show you a couple items. This is a constant cost industry, and what that represents is the supply function is going to be perfectly elastic. Now that doesn't mean crap right there until I show you the rest of this. Okay, so let's try something once here. All right? This is kind of what we were doing before, but let's try this. I need to darken that a little bit, you guys, I think. Let's go here, let's go here. here. Okay. Right here, you're in long run equilibrium. But notice, here's your supply and demand function, S1, D1. Notice there's been an increase in the demand for the product. Earthworms. Let's try that once. Anybody can do it, you can find them anywhere. The equilibrium was at $50 here for a bucket of earthworms. But the demand rose. If the demand rises, what's your new equilibrium price? It's up here. What is the firm recognizing when MR equals MC now? You want me to draw that here? Well, we've got an increased quantity. Okay, are we earning a profit right now? Is the price greater than the average total cost of producing the item? It is, isn't it? So this is all profits, isn't it? That's all profits. Now, because it's so easy to make and profits are being earned in the industry, what's going to happen?
Prices will fall again.
And why are they going to fall? Because more people are going to enter, aren't they?
Yeah.
Everybody see that now? Pretty easy, isn't it? And that's why that's that long run equilibrium. Okay, so in a constant cost industry, you guys are pretty smart. A lot of times, all right, if the demand increases for the product, is there an increase in the demand for the laborers to go pick up the worms? Is there an increase in the demand for the, all right, the containers that you have to put the worms in? So normally what happens to the cost of your inputs? They go up, don't they? So when they say it's a constant cost industry, you're going to notice that then when that supply curve shifts, it goes back down to the original price. Now, in theory, that doesn't happen all the time, you know. We're just assuming that no matter what, whether there's shift in supply or demand, are we always going to return back to the original price? We are, aren't we? Because all the costs are constant. Nothing's changing. So that's what that means if you see that. Okay? I don't know on a Clep, but boy, you'd see it on AP for sure. Okay, I think a really good way to show this once again, we'll show you another example, increase in demand and then an increase in supply to bring the prices back down to the long run equilibrium. And so look at your supply function in the long run. Now, I know we talk about this stock, we're saying, well, supply and demand curves, all right, are upward and downward sloping, but the long run supply, no matter how often the demand and supply shifts, reaching out here into more and more production, it's always going to be the same. In a normal situation, that's most firms, all right, are going to be increasing cost industries, not constant. But at least you can see this example. Here's another example. What if demand decreased in the industry? All right, let's say that this is our long run equilibrium, supply and demand at S1, D1. You guys can see that. What if demand fell for worms? It's fallen. Then what's going on? Well, prices fell below. Well, now if we produce at MR equals MC, okay, notice that the price is lower than the average total cost of producing it. Then this would all be what? Loss, wouldn't it? And you'd be able to calculate that, all right? So then what would happen in the long run? Well, if there's losses in the industry and everyone can do it, people are just going to get out, aren't they? Easy entry and easy exit. And the supply function will shift then to where we're back at what? Our long run equilibrium. I am telling you, if you can do a good job with peer competition, does the rest of your life, is it easy then moving forward to the other models? And most of the questions you guys are going to be on PC. You just got to trust me on that. And it's kind of weird because it's hard for us to come up with an example of it, correct? All right, here is an increasing cost industry. And you're going to be looking at this, you're seeing stock. Now, what the crap is going on? Our supply function no longer is elastic, but it's kind of like we normally see it. It's sloped upwards. So here's why, without me reading through all of this, you guys have the notes available, okay? Just let me show you what's going on so you don't panic here.
It's a crash course. Now notice what's happened here. Boy, that looks confusing, doesn't it? That's a mess, but it's not. It's not. All right? Here is our original demand and supply function right here. Here is our long-run equilibrium. Does everybody see that? Okay, we're at minimum ATC. Everything is in accordance with our rules over there, but now the demand has shifted for the product, hasn't it? Okay? But notice when the supply, we said when the demand shifts, we're showing profits, right? And then suppliers are gonna step in and make it and bring us back down to this long-run equilibrium, but they can't. See, because when that demand increased, was there also an increase then for the buckets, for the worms, all right? Is there an increase for our laborers and all that stuff, right? So the supply, all right, doesn't shift as far, and it actually represents an increasing cost industry. Since there was such a surge in demand for earthworms, we can't return back down to our equilibrium. Does our equilibrium change? It does. Increase in demand, profits are being shown, right? More people enter the industry, supply shift. It's just that the supply shift isn't equitable to the demand shift, and that's because your resource prices went up. Now what happens then, take a look, here's your new price, but are we still at long-run equilibrium? We are, because what happened is your long-run average cost function is gonna shift upward, and so is your marginal cost because your cost went up. So they'll have some questions, like in an increasing cost industry, which of the following might happen? So I think it's really wise of you, if they don't have a picture of a graph, just to draw a little one on the side, and now you remember that long-run supply function is shifting upwards. You're still in long-run equilibrium, it's just that your costs increase. And I know that looks kind of confusing, but now when I've talked about it, is it easier? Because could you also have then a decreasing cost? I gotta go over here, Jack, I'm a loser.
Okay.
All right, do you have a decreasing cost industry? This is rare, okay, but it could happen. Once again, pure competition, we can tell our marginal revenue curve is perfectly elastic. We're in long-run equilibrium now here. Okay? Right here. Demand picked up for our product, correct? And then a whole bunch of firms got into the industry. Now, why did that supply function shift so far down that notice the price and the cost even for the firm shifted down? When you see all those cost functions shift down, that means their cost fell too. Are you still back in long-run equilibrium? Yeah, you are. But why did it fall? Economies of scale. If the demand for the product rose, driving a whole bunch of suppliers in, all right, do some of those firms that come in then achieve lower and lower costs of production because of better ways of producing things? So your supply function actually in the long run decreases. Now you guys know that as more and more firms get into the industry, they find better ways of producing things. And the prices go down. That's what they're really referring to here. Okay? What do you think there? Pretty easy? Anybody have any questions there? And like I said, I know I'm doing this crash course, but okay, so is pure competition efficient? It's the ultimate efficiency. Okay? Now what the crap are we talking about here? In the long run, PC is productive efficiency. Do you remember what productive efficiency is? Who can tell me? We're in trouble. We're in big trouble right now. What's allocated efficiency and productive efficiency? We are all in trouble. Yeah?
Productive efficiency is anywhere along the curve.
You're good. Remember now, in class, I said, don't forget our PPF model. It's gonna come back later, not only in international trade, but when we do this stuff.
if I'm not mistaken, now it's gonna be bowed outward because our resources generally are what? They're not perfectly interchangeable, are they? So that function is gonna be bowed outward, concave to the origin. And let's try this once, okay? The kickster is saying that any combination on that function is productive efficiency. What did that mean again? Are all laborers being employed to their lowest possible cost? Are all machines functioning at lowest possible cost? Correct? Well, isn't that where the price would be equal to the average total cost of producing the item? The price that exists in the marketplace is equal to that, and it's equal to it where? At the very bottom of the average total cost function. Sometimes kids have a hard time equating our PPF model, guns and butter, with the firm and, all right, the output that it's producing and the prices. So what are we going to put here for this? This is going to be productive, all right, efficiency. Okay? What is P equal to MC? What is allocative efficiency again, Kickster?
Where they produce
The what?
It's where they produce.
Is there any point on this function that's any more efficient than any other when it's on the function? All laborers are produced, we're just producing a different combination, correct?
Yeah.
What's allocative efficiency?
Right mix.
Exactly. And where is the right mix? Where price is equal to what? MC. This is the right mix, the right stuff. All right, so this is allocative efficiency. So if you see that, all right, on the test, something called triple equality, I want you to take a look at that combination once.
Watching it after. Yeah,
I just looked at it.
I could hear you looking at it.
I just looked at that. I am not trapping you. Last night.
I could
I
sense
almost
that, so I ordered them.
You dog.
Good morning, students. Just a reminder,
Does this make
sophomores,
sense
if you're
now?
testing this morning, you
Where
should
P
each
is
first
equal to the
breakfast.
marginal cost,
You
where
will
it's
not have
equal to
an
minimum,
opportunity for second chance. Again, sophomores testing this morning, please make sure you
average
eat
total
breakfast
cost, we call the triple
before
equality.
school. Thank you.
No, watch, what do you, Slack, you're saying, what the crap's going on here? Consumer and producer surplus is maximized. What, we're talking about that again? Yeah, we are. Because remember, all right, the industry is setting the price, and can I draw, all right, a supply and demand function right over here? I can. Isn't this what? CS and this is PS? It's maximized. Pure competition is beautiful. And if you look at this next slide here, let's take a look at it right there. The long run equilibrium is producing at these points, and we get really, really efficient outcomes. Okay? Here's our definitions, the right mix and also productive efficiency is any point on that combination. It's fully efficient, doesn't matter where, it's just different combinations. That's it. All right, that is a slam dunk on that. Now notice that I'm gonna jump to monopoly. You said stock, well, why did you jump all the way to monopoly? That's usually what the textbooks do, and it's kind of easy making that jump, all right? So it's the antithesis of pure competition. I think what we need to do today, all right, let's take a look at this and compare the two. Now, it's imperfect competition. Everything's imperfect competition besides pure competition. Right away, we know that's pure competition. We know it's the long run equilibrium, all right? And right away, all right, when I look at this, that could be either, all right, that could be a monopolist graph, or it could be a oligopoly graph, depending upon which one. And it could also be MC. And then you're saying stock, well, now you're really losing me. I'll show you over here, okay, in a second, but what do you think that AR function is right there?
Average revenue. maybe.
What do you think that is? It's your demand function. Now, in perfect competition, the demand function is perfectly elastic, all products are the same. If it's MC, if it's monopolist, if it's oligopoly, this thing is gonna be sloped downward, all right? We all know that. Because as the prices change, and if we increase the price, we're gonna sell fewer of them, aren't we? Because are people gonna go buy something else? Not all the products are identical. Make sense? Okay, so now, where's your MRMC rule? All those rules are the same. It's just we have to develop a marginal revenue function. Now, how are you gonna get a marginal revenue function? Marginal means one additional, correct? So if marginal cost was a change in total cost or variable cost, what is marginal revenue? A change in what?
Total revenue.
Total revenue. And how can we come up with total revenue? Well, let's try something over here once, okay? Maybe I could make some stuff up here. I could go 1, 2, 3, 4, 5, 6. Let's do something like this once. Let's make something up. Let's make this 6. Let's make this 5. Let's make this 4. Let's make this 3. Let's make this 2. And let's make this 1. Let's just make it really easy. Something like that with a 45-degree angle. Pretty easy stuff. Okay, so let's set this up. P times Q is equal to total revenue, isn't it? Pretty simple stuff. So, and you know what we could do? We could even do something like this. If you want to be really creative, let's go over here and let's make that 7. So at $7, and remember this is P and this is Q, at $7, is there any demand? There's none, okay? We can certainly do that. What I'm gonna do to, I think, to show this to you so it's a little bit easier, I'm gonna start here with quantity 1, 2, 3, 4, 5, and 6. All right, and I'm gonna do that for a reason, okay? And we're gonna go 6, 5, 4, 3, 2, 1. How does that sound? All right, but if we wanted to go to 7, we could do that. Let's go to 7, there would be 0, correct? You guys with me so far? So what is our total revenue here is 0. What's our total revenue?
6,
6.
10, 12, 12, 10, 6.
Could we develop a marginal revenue function from this? I think we could, couldn't we? Okay. What's the marginal revenue then of producing the first item?
6.
6. What's the marginal revenue? Now we're moving from 1 to 2. What is that?
4.
Okay, next.
2.
Next.
0.
Next.
-2.
Good. Next.
-4.
Very good. Very good. Wonderful. Okay, so I think now what we should do is maybe we should plot that. What would our marginal revenue function look like? Remember, this is going to be true for what? Oligopolies and monopolistic competition as well. Do they face downward sloping demand functions? They do. So do you now notice that the marginal revenue function is always going to lie underneath the demand function? All right. Marginal revenue is a product of the demand function. That's how we derive it. This firm faces this demand function. Okay? Does anybody notice anything else going on here in terms of elasticity? Remember we talked about this the other day when I was looking at elasticity. I said you need to know this. Are there certain sections of the demand function that are elastic and inelastic? Can you see that on this graph at all? I think you can, can't you? Watch once. When I decrease price, my total revenue actually what?
Increases.
Increased. What section of the demand function is that? Elastic or inelastic?
Elastic.
Very good, Pedro. When I decrease price, all right? Oh no, what happened to my total revenue? It fell. So now you're decreasing prices in the what area?
Elastic
In the
area.
inelastic, aren't you?
Inelastic.
If you're a monopolist, what level of the demand function would you want to always produce in? That's going to be a question on the Clep. It's always on there. It's going to be in the elastic section. Okay, because the monopolist has, you know, in order for them, all right, to make more product, what do they have to do when you're looking at the demand function? If they want to increase their output, they want to make more widgets, what do they have to do if they're faced with that demand function? They got to lower price. And you only want to do that in what section?
Elastic.
In the
section.
elastic. So let me show you, this is cool stuff. All right, we're going to plot this now. When we move from 0 to 1, I don't want to stand in the way here, it's bad teaching. 0 to 1, what's our marginal revenue? 6. When we move from 1 to 2, what is it? 4. When we move from 3 to 4, or what are we going? No, we're going, I went 0 to 1, 1 to 2, now 2 to 3, I'm sorry. When we move 2 to 3, what do we have? All right, it's going to be right here, it's going to be 2. How about when we move from, all right, 3 to 4? 0. Okay, look at this.
Haley Blake, Lenny Santana, Haley.
Now, when we move from 4 to 5, what do we have? We have a -2. I haven't drawn this right. Look at what we have. I'm going to do something here once. This is going to be the what? Elastic section of the demand function. Do you think there's going to be a question about this x-intercept then with that marginal revenue function? Yeah, there is. And now everybody understands what it represents, don't you? That's the elastic region of the demand function. Now we all know, all right, that, let's take a look at this. Let's go over to this graph. I was just showing you how that works, that marginal revenue function, okay? Let's go over here. Does the monopolist, oligopolist, every firm always produce at MR equals MC? Yeah. But you're gonna notice that quantity that they produce, the price that they'll receive is the demand function. You just follow that up to the demand function and that's your price. Now we could put some numbers on here. We could say that at that quantity, we're maximizing our profits, we're gonna say the price is $10. But you'll notice, what's the average total cost of producing it? Let's make something up. Does it look like about 7? Does that look about right? So could you calculate then the total profits? Well, it's a distance of what? $3 per item, and you produce 6 items. So what would your total profits be?
18.
18 bucks. All right. All right. Now this is really hard to get into. It's no easy entry and easy exit, is it? Nope. So, will the monopolist earn profits? Yeah. Are you getting as good a deal as pure competition?
Yeah.
Watch. Price is greater than the average total cost. So we don't have what? We don't have productive efficiency. What other thing is going on? Price is greater than the marginal cost. We're not getting allocative efficiency either, are we? Not at all. So that's why we compare the two items. Now, what we need to go through when you come in here tomorrow, and I'm going to polish off monopoly fairly quick so we can get to MC. Does anybody in here see dead weight loss
Yeah.
with the monopoly? We're going to go over that tomorrow. We'll look at some of those things. They're going to ask you about that. You know, identifying dead weight loss with the monopoly. They're going to ask you questions about how should you regulate it. Could you compare the two? You know, and what should you set the price at? It's pretty easy stuff. I just got to show it to you. All right. Now, what I'm going to do in the meantime, I'll go through and I'll separate all these books. For those of you that are late, the college professor passed away, and I inherited all of his textbooks here. Not the student ones, but ones that he had. I know that Some of you I do have the online textbook, but maybe some of you want a hard copy. I'll go through and I'll look at some of these companies. I know many of them, and then I'll have a stack here if you wanna check one out or something, okay? It's kinda cool, isn't it?